Okay, Module 3, Lesson 4, you are going to need to get out a sheet of paper, and you're going to need to do this with me as we look at the fundamental theorem of similarity. And we're going to use this because we need this. And you're going to need a calculator, a protractor, and a centimeter ruler. So go ahead and get those things out as well. Okay, these things, all these things. Okay, we're going to use those. So get those out and have those handy and ready. So we focused on dilation, and now we're going to use dilation to come up with some conclusions about the concept of similarity. And this is a good tool to use for similarity because of the lines it has on the paper. Okay, these lines are parallel to each other, so we're going to do that. Use that for this purpose. First, you're going to take a pencil and you're going to mark a center O on there, or a writing utensil. I'm going to start right here. I'm going to label it O. Now, you can mark yours in somewhere else, or you can do it along with me exactly how I do it. It's up to you. Okay. Now, mark a point P a few lines down from center O. So, I'm going to go a few lines down right here, and I'm going to mark point P. And once I have that marked, I'm going to take my ruler and I'm going to draw a ray through point P. Rays have arrows. Okay, and then I'm going to mark another point on the line right here, and I'm going to label it P prime. And then I'm going to look at this. Now we can calculate the scale factor by the definition of a dilation. So if we remember what the definition of a dilation, it's the distance from O to P prime equals the scale factor times the distance from O to P. And what we're going to do is we're going to use the distance in the lines as our unit. So the distance from O to P is 1, 2, 3. And the distance from O to P prime is 3, 4, 5. So to solve for our scale factor, we're just going to divide both sides by 3. Then these cancel, and our scale factor would be 5/3. Okay? So we could figure our scale factor by just looking at the paper. And now we're going to draw another ray OQ using the same scale factor. So on this from O, I'm going to go down 3 lines and I'm going to put a point. And I'm going to put it way over here just because I feel like putting it way over here today. And then I'm going to go down 2 more lines. Well, no. I'm going to draw my ray. And then 2 more lines down, I'm going to put Q prime. So my scale factor is still 5/3. 1, 2, 3 would be the distance from O to Q. 4, 5 would be the distance from O to Q prime. So I still have the same scale factor. Now we're going to connect points P and Q and P prime and Q prime. When I connect them, when we connect them, what do you notice about those 2 lines? Those 2 lines are parallel. Do you guys see that this line is parallel to this line? Okay, so we're going to use our protractor to measure OPQ and OP prime Q prime. Okay, so that means we're measuring from O to P to Q. I'm not able to do that. It's not on the outside, so I'm going to extend this line this way. So when I line this up and measure it, I get 35, 6, 7. So angle OPQ equals 37 degrees. Now, yours won't be exactly like mine, and that's totally fine. And I measure this one, again, 37 degrees. Angle OP prime Q prime is 37 degrees. Okay. So, these two angles are congruent, and we know that these are parallel lines. So we know that this angle here, let me use this, here is a corresponding angle here. So that's why they're the same. They are corresponding angles. Angles of parallel lines. Okay? So without using your protractor, what can you say about angles OQP and OQ prime P prime? So angle OQP and OQ prime P prime. Angle OQP and angle OQ prime P prime. So if we look at this, these again are corresponding angles, so they're going to be equal in measure. Because they're corresponding angles of parallel lines. Okay? So now we're going to measure some lengths here. We're going to measure from O to P and O to P prime. And then I would venture to say we're probably going to do the same thing for O to Q prime. I'm going to turn it this way so it's easier for me to measure. 3.1. So, let me go over here. The distance from O to P equals 3.1 centimeters. And the distance from O to P prime is, you could say 5.9, maybe, I'm going to go with 5.9. Okay. So if we did this, we would say, okay, 3.1 times 5/3. Did I measure that right? Yeah, I did. Okay. If we took this and multiplied it by our scale factor, we should come up with the same thing. Oh, see, I can't measure correctly. That's 3.6. See, having a rough day of measuring. Times 5/3, 6. So it was about 6. It's about the same. When you draw these and measure them, it could be off within a tenth, and that's okay. But you do see that this is the length from O to P prime is 3.6 times 5/3, which gives us the 5.9. Okay. And then we would do the same thing for O to Q. The distance from O to Q, 4.4 centimeters. The distance from O to Q prime, 7.4 centimeters. And let's see if that works. 4.4 times 5/3. Pretty close. Okay. So we have some stuff to think about here. What do you think would happen with the relationship here? The relationship from O to P and O to P prime. We've kind of have talked about that a little bit. Okay. You should know that if we were to measure this and dilate it by a scale factor of 5/3, we should get, so if we measure the length from O to P, and multiply it by the scale factor of 5/3, we should get the length from O to P prime. And the same thing on this side. Now we're going to look at the segments in between. So we're going to say the length of PQ actually, I'm going to go this way. The distance from P to Q and the distance from P prime to Q prime. We're going to see if they have the same relationship. Okay, so the distance from P to Q is 6 point, I'm going to go with 8. And the distance from P to Q prime, 11.3. And let's see if that works. So 6.8 times 5/3, 11.3. So it does have the same, the dilation does have the same result on the lines that are parallel to each other. Now, if we did this and we added another point on here, say I put a point here and called this A, and I drew a line from here through here and called this A prime. Everything that happened here with the distance from O to P and O to P prime would be the same for O to A and O to A prime. Still a scale factor of 3. These angles would still be the same, corresponding angles of parallel lines. The distance from O to A times the scale factor would be the distance from O to A prime. And the distance from P to A times the scale factor would be the distance from P prime to A prime. Okay, so you could add as many points in here, but all of these things that prove true would be the same, no matter how many points you add into the diagram. So we have experimentally verified the properties of the fundamental theorem of similarity in terms of a dilation. So that means that parallel line segments connecting dilated points are related by the same scale factor as the segments that are dilated. So no matter which segments we're talking about, it's going to be the same no matter what, because we've used the same scale factor. Okay? So now that we're more familiar with the properties of fundamental theorem of similarity and of dilation, we're going to use those in the next few lessons to verify similar figures. But before we get to that, we're going to look at this problem right here and work through it. So in the diagram below, R and S have been dilated from center by a scale factor of 3. Okay. It's always good to identify your center and your scale factor. Okay, it's good to know that. If the distance from O to R is 3 centimeters or 2.3 centimeters, what is the distance from O to R prime? The distance from O to R prime equals 3 times the distance from O to R, which would be 3 times 2.3, which would be 6.9 centimeters. Okay, if the distance from O to S is 3.5 centimeters, what is the distance from O to S prime? So the distance from O to S prime equals the scale factor, which is 3, times the distance from O to S, so 3 times 3.5, which would be 10.5 centimeters. Oh, you couldn't even see that. Sorry. So same concept here, just looking at the fundamental theorem of similarity a little bit here. On C it says connect points R to S and R prime to S prime. What do you know about the lines containing segments RS and SR? So when we connect these lines, okay, connect them. Okay, if we look at these lines, we should know that when we dilate using the same scale factor, that this line and this line are parallel. Okay? So we would say the lines containing segments RS and R prime S prime are parallel. And then it says, what is the relationship between the lengths of the segments RS and the length of the segment R prime S prime? Okay. So we're going back to knowing that the fundamental theorem of similarity. We have this segment, we dilated it by a scale factor of 3. This segment should be 3 times as long. So R prime S prime is 3 times as long as RS. So segment R prime S prime is 3 times as long as segment RS, and that's because of the definition of a dilation. So the length from R prime S prime equals 3 times this length of RS, definition of a dilation. Identify pairs of angles that are equal in measure. How do you know they are equal in measure? So if we look at our diagram, we will know that ORS, this angle, and OR prime S prime are the same angle measure. And then going the other way, OSR, this angle right here, and OS prime R prime, this angle right here, are equal in measure. If you look at them, they are corresponding angles of parallel lines. Okay, so this is what I'm going to write over here. Angle ORS and angle OR prime S prime are equal in measure. Angle OSR and angle OS prime R prime are equal in measure. And both sets of angles are corresponding angles of parallel lines. Okay, so in the end here, okay, we know the theorem, and it is here on this page. Okay, so we have a center and a scale factor for any point, 2 points, O, P, and Q don't have to be collinear. They don't have to be on the same line. The lines O or PQ and P prime Q prime are parallel when there's a dilation of P and Q using the same scale factor. Okay, so all this is showing is that when we have this diagram, we use the same scale factor. The segments, corresponding segments, are just multiplied by the scale factor. Corresponding angles are the same angle measures. That's all we're coming away with here. Okay? That's the fundamental theorem of similarity.